let's say I have a chocolate bar, and what I do is melt that chocolate bar. Then what would happen if I have a chocolate bar and I melt this chocolate bar? What will I get? Melted chocolate. So it will still be chocolate basically, but it will be just what, in its liquid form basically. Yes. So if I melt the chocolate, it will still be chocolate. This is the main logic. Correct? In the same way, if I have ice and I melt it, what would I get? If I heat ice, I'll get water. In both cases, it is the same thing. I do not have a different or a new substance produced basically over here. It's still the same thing, even though I've changed the matter. I've changed the state of matter, but still it's the same thing. So such type of change is known as a physical change, where no new substance is formed. Correct? In a physical change, substances present remain chemically the same. No new substances are formed. The substance remains chemically the same, even though we have a change in state of matter. Second point, physical changes are often easy to reverse. Any mixture produced are usually easy to separate. So if I get chocolate which is melted, if I put it back in the freezer, will I get the chocolate bar again? Like, will I get my chocolate back into its solid form? Yes or no? Right? Okay. So this is an example of a physical change. Now tell me another thing. If I have an egg and I heat this egg, would it be the same? No, it will it will change, right? It will turn into an omelette or a half fry, or if I boil it up. In boiling also I'm heating it. Then it will be turned into a boiled egg basically. In this point I'm boiling it. In this case I'm making a half fry. In this case I'm making an omelette. Will you all agree with me or no? Yes. So what example is this? This is an example of a chemical change. So basically, what is a chemical change? In a chemical change, we will get a new substance after that chemical reaction has taken place. This is what you all need to remember basically. So it will be, chemical changes are the result of chemical reactions. For example, when magnesium burns in oxygen, the white ash produces a new substance. Burning magnesium produces a brilliant white flame, energy is given out. So we are getting a new substance. So therefore, chemical changes are what? Are changes which create new substances. Whereas physical changes are the changes in which the substance remains chemically the same. No new substances are formed. Or usually, what happens? The state is changed basically. That's it. So I will be sending you the PDF. I want you to learn this part from the PDF. Then what this part? See, the major feature of a chemical change or a reaction is new substances are made during the reaction. Many reactions, but not all of them, are difficult to reverse. Whenever a chemical reaction takes place, it is difficult to reverse the whole process. If I boil or heat an egg, can I get the original raw form of that egg back? No, it's an irreversible reaction, and a chemical change has taken place in it basically. Now you see this exothermic change and endothermic change written over here. My question is, what is exothermic change and what is endothermic change? See, what are they saying? During a chemical reaction, energy can be given out or taken in. And in bracket, they have written exothermic change and endothermic change. So, if I say that something is producing an exothermic reaction, like when I'm combining two things, they are creating an exothermic reaction. What would that mean? No, not energy. Yeah, yeah, you can say energy. Basically, heat is released in the surrounding. In an exothermic reaction, what happens? Heat is released in the surrounding. What is heat? Heat is energy. Okay? Heat energy. Heat is actually energy basically. So, energy is given out in exothermic reactions, is given out in the surrounding, in the environment. Whereas in an endothermic reaction, the heat is given in, it is taken in basically. So, it is absorbed from the surrounding. An example of an exothermic reaction would be what? Burning wood. If I burn a wood, it is an exothermic reaction. That wood, while burning, it would produce heat and it will give that heat off into the surrounding. An example of an endothermic reaction would be the melting of ice. If I place an ice cube on a table and I let it stay over there, what would happen? After a while, I'll see that it is melting. Why is it melting? Because it absorbs the heat from the surrounding. So it is absorbing the heat from the surrounding, it's taking in energy from the surrounding, and hence it is gaining heat. And what result do we get because of that? It starts to melt. Is this part clear to everyone? All right. Fourth point. There are many more exothermic reactions than endothermic reactions. So in a chemical change, what do we have more? Exothermic reactions are more than endothermic reactions. So you all have to properly learn all these properties of chemical changes. See this, state whether the following change are physical or chemical. This will be your assignment. You will be solving this question and telling me whether melting of ice is endothermic or exothermic. You have to tell me whether it is a physical change and a chemical change. Also tell me whether it is an exothermic reaction or an endothermic reaction. Tell me about this as well. Now, here it is, exothermic and endothermic reactions. Let's jump. See this. The thermal energy released in these exothermic reactions lead to an increase in the temperature of the surrounding. The surroundings include what? The reaction mixture in the test tube, the air around the test tube. What are the topics? They are basically dissolving magnesium chloride in water in an exothermic physical process. Adding zinc to copper sulfate solution is an exothermic chemical reaction. So what was thermic chemical reaction basically? During this reaction, the thermal energy is released. The thermal energy released in these exothermic reaction leads to an increase in temperature. Obviously, I just told you that burning wood is an example of what? An exothermic reaction. So would my temperature increase? If I am uh, heating anything, I'm telling you that it is an exothermic reaction because the heat is being given off into the environment. Yes, my temperature will increase. So, in an exothermic reaction, what is the first thing that you must remember? That it changes temperature. How does it change temperature? It increases the temperature. Is this part clear? So far? Alright, okay. The air around the test tube itself, the thermometer, or anything dipping into the test tube, all of them will be affected during the exothermic reaction. So if you want to always think of what would happen in an exothermic reaction, the first basic thing is think of a wood that is burning, and then imagine how would that burning wood affect the surrounding. You will be able to feel that heat. So what else would be happening? The temperature would be increasing, the air around it would be also getting hotter. Yes, the wood itself would change its state. It will keep on burning all the way down. So you have to remember all these examples. Example here. Exothermic reaction give out heat. So see these keywords. Endothermic reactions take in heat. First they were using the word energy. Now they are using heat. So heat is basically energy. Do not forget this. This page. This is the most important part of the chapter. You come across these diagrams a lot. So what's happening over here? See, in this reaction, what do we see? Methane is reacting with oxygen and producing what? Carbon dioxide and water. Now, in this reaction, the first thing that we must know is whether it is an endothermic reaction or or an whether it is an exothermic reaction or an endothermic reaction. Now see, remember this, that whenever heat is given out, it is an exothermic reaction. And when heat is given out, that means the substance that is producing that heat, its energy is decreasing basically, because it's giving off its energy into the surrounding in form of heat energy. So therefore its own energy will be decreasing. Do you get my point? So see in this example what's happening. CH4 and O2, we are reacting these two things, and when we react them, what do we get? Carbon dioxide and water. So during this reaction, what is happening? You see this table here, this graph here, it goes downwards and then again it goes horizontal like this. What does this mean? It means that when this reaction took place, what happens? Whenever this reaction takes place, guys, 1 minute. Alright. So, whenever an exothermic reaction will take place, this arrow will go downwards, indicating that there is loss of heat energy. In an exothermic reaction, as heat is given off, therefore we will have loss of heat energy. Hence, this is the bar of the energy. It is going to go downwards. So if you ever come across a pathway diagram that looks like this, you must remember that it is a diagram that is representing what? An exothermic reaction. Is this part clear? Okay. So for an exothermic reaction, you can see that the energy of the reactant is higher than the energy of the products. So make notes from here. You must remember that whenever we have an exothermic reaction, the energy of the reactant will always be higher than the energy of the product. Remember this part. The black arrow points downwards to show that the energy is given out or released. The energy is being released. Basically, that's why they are indicating it with a downward arrow. Let's talk about an endothermic reaction now. This is a reaction taking place basically. N2 plus O2 are giving me what? Nitrogen, NO basically. This is the equation over here. Nitrogen monoxide. So I'm getting nitrogen monoxide. What's happening here? You can see in the reaction, these two elements, these two molecules, basically not elements, these two molecules are reacting with each other and forming a bond. Simple. So it is an endothermic reaction. This reaction, basically, this nitrogen monoxide is usually made when we burn the fuel in car engines. Then nitrogen monoxide is basically produced. So in this reaction, what type of reaction it is? It is an endothermic reaction. What happens in an endothermic reaction? This is a reactant. This is also a reactant. And these reactants are producing these products over here. So in this case, you can see that the energy of the product is higher than the energy of the reactant. In this case, you can see the energy of the reactant is higher than the energy of the product. So in an endothermic reaction, this is what you write. Energy of reactant is lower than the energy of products. And this arrow indicates that the energy is being absorbed over here. Is this part clear? Okay. Take a screenshot of this as well. Now, there is this term called enthalpy change. What is enthalpy change basically? You find the difference between the heat energy, that is known as your what? Enthalpy. It is represented by this symbol over here, delta H. This is known as your enthalpy basically. So the thermal energy content of a system is called the enthalpy of a system. The transfer of thermal energy during a reaction is called the enthalpy change of the reaction. What are they telling us here? When heat is released from the system to the surrounding in an exothermic reaction, the enthalpy of a system decreases. When heat is released, enthalpy decreases. When heat is taken, the enthalpy increases. Can I say that the heat energy and the enthalpy are inversely proportional to each other? Yes or no? If I say the more the heat is released, the lower will be the enthalpy change. Yes or no? Yeah. Which part, beta? This enthalpy part? Okay, I'll tell you again. See, what are they telling us over here? I'll tell it again. Look, they are saying when heat is released, the enthalpy of the system decreases. So basically, the enthalpy is decreasing, correct? And when the heat is absorbed, when the heat is absorbed, the enthalpy increases. When we have an basically endothermic reaction, it means that heat is given in such a case, you must remember that the heat energy, the enthalpy of that system will increase whenever we have an endothermic reaction or whenever heat is absorbed. What would that result in? That would result in increase of enthalpy. Is it clear now? Okay. In the same way, when we have an exothermic reaction, we know that heat is not given in but given out. And in such a case, what would happen to the enthalpy? The enthalpy decreases. Do you all get this now? Now, one more thing that you all must remember is when the heat is released in this part, when we have an exothermic reaction, in such a case, the enthalpy, when the energy is given in, then it will be positive, and when the energy is released, in this case, then it will be negative. Because we are giving off energy, we are going in minus, therefore it will be negative. You have to remember it like this. Okay? All right, now do memorize these definitions. And yeah, I guess, yes, yes, I'll frame everything. I'll frame the definitions and all these examples as well. Okay? I guess you all should start memorizing till this part, because this is another logic of bond breaking. I will teach this to you guys tomorrow. Tomorrow we will complete bond breaking and activation energy.